Morning, everyone. Uh, my name is Akshay, and I'm an IoT engineer in Napino Digital Solutions. So, is my screen visible? Can anyone just confirm? Yeah, I think. Okay. So, I hope everyone is good right now because of COVID. Okay, let's start with it. So, this is the agenda of my session. So, Arduino on an emulator. So, in this session, we'll be covering these topics. Introduction to Arduino. First of all, what is Arduino? What are it like pinout diagrams, and what type of, like, is it a controller or a processor? Why we use it? Why Arduino? Then how to code on it, like Arduino Ide and its usage. Basic functions. How can we do our DIY projects? Then we have like what are sensors and actuators, then the structure of code, like what is the structure of code that we follow in Arduino IDE, then what is Tinkercad and simulation on Tinkercad, like because due to COVID we'll be doing it on an emulator, and then we will be doing live simulation in which we will code and actually run some few DIY projects so that you can start and like do the basic tinkering with your hardware or even on Tinkercad. I think my video is off. Yeah, I think. Okay. So yeah, introduction to Arduino. So as you can see, it is a Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 GPIO pins, general purpose input output pins, of which 6 used to be as PWM, which you can see on the right hand side. Digital PWM is a very good technology. It uses the amount of power delivered to a device that can be changed. Like it basically generates analog signal by using a digital source. Like as you know, like anyone can tell me what is the difference between an analog signal and a digital signal? You can unmute yourself or type in the chat box if you want. Okay, no issues. So it generates, as I said, it generates an analog signal by using a digital source. What basically it does is it like creates a square wave, which is like switch between on and off state. Then we have 6 analog inputs through which we can access analog sensors, which give like different values. Like the digital input will only give me 0 and 1, while the analog will have a full cycle. It can give me inputs of like different ranges depending upon the sensor we are using. Then we have a 16 megahertz quartz crystal. It generates the clock signal. This device like has been developed to function as a reference signal generator for the Arduino. Then we have a USB connection, which is used to like burn the program, like burn our firmware into the Arduino. And then we have a power jack, which like after flashing the Arduino, like the program on Arduino, we can use a power jack and directly like deploy it anywhere. Then we have an Icsp header, which you can see here, like Icsp2, and one is beneath. This is a very good thing in Arduino. Like these pins enable the user to program the Arduino board's firmware, like when they have like destroyed the USB connection or anything like that, they can directly hook up their programming cable and they can directly program it. Then we have a reset button over here, through which like we can reset our, like if by any chance you program something and that is like that made the Arduino stuck on a phase, then you can just press the reset button. It will just go back to the starting of the program that is being flashed into it. And it supports like I2C, SPI, and UART 3 protocols. Now, anyone have any questions in this slide? I'm unable to see the chat box.
Okay. Akshay, I'm looking at the chat box. Don't worry. So there is no question. But
Okay.
everyone. If you have questions, you can also unmute and ask the question so that we can keep the session interactive. Yeah.
Okay, now moving on to the next slide. Okay, so sensors and actuators. Can anyone tell me, like, I want it to be a like interactive session. So anyone have any idea like what is a sensor and what is an actuator? Like you can unmute yourself or type in the chat box.
Hello, hi sir.
Hi Kishore, how are you?
Yeah, sir, I'm fine, sir. You?
All good.
Yeah. Yeah, I just wanted to give a difference like that so that I can answer the question. Sensors as the component gives a digital output and actuators gives a analog. I'm right?
Sorry, I didn't get your question. Can you please repeat?
No, I just want to answer actually.
Okay.
For sensors,
Yeah.
it will give digital output.
Okay, and for actuator?
It can give a analog output also.
Okay. Anyone else want to give it a try?
So sensors are the one which are used to sense the environment or read the value, be it analog or digital, and actuators are used to affect the environment depending upon some processing. After processing, we would affect the environment probably through a mechanical action or any other action.
Yeah, that is the answer I was looking for. Okay, now, so yeah, as she said, so sensor is basically an electric component that sends some signals and its responses in the form of electrical data. For example, PIR sensor, or like to be like completely like raw with you, like we humans have senses like our nose. So like sensors are like a PIR sensor or anything that takes the input from the environment and gives the electrical signal to the board, to the microcontroller or microprocessor, whatever you're using. Then we have an actuator. Like for sensors, there are like temperature sensor, pressure sensors, and many other things. Now coming to actuator is are those electronic components that converts electrical signals in form of energy. For example, a speaker, a motor, or like the very basic example anyone can give me of an actuator. Like we see in our like daily life, we turn on the switch and we see the example. Any actuator that you can name right now? Okay, no issues. I'll name them for you. So the very commonly used actuators that we use in our daily life is LEDs, like LED bulb or a fan. We don't have a microcontroller right now because like they are not IoT enabled. But yeah, these are like basic actuators. We give them signal from our switch, we turn them on, and they get the signal. And they just like we can see the electric energy into like we can see a electrical signal into an energy form. Yeah, moving on to the next slide. Yeah, so sensors to actuator flow, like we got to know what are sensors, what are actuators. Now we like what are the purpose of it, like what is the bigger picture. So like in a typical IoT system, a sensor will collect information and route it to a control center, which may be like on the edge, like without internet, or it may be on a server. Like the main thing that sensor does is grabs the raw values and send it to the server, or on like locally also in some cases. Then like the control center or like the controller have like previously defined logic that like dictates the decision. Like if this, then that. Like if temperature is low, then turn on the fan. If like I'm seeing a light, then turn on the like if like there is no sunlight, then turn on the lights in your room. Then as a result, like a corresponding command control and actuator in the response to like when like for example, when our sensor sense the like up koi, like there's no light around, and it's then it sends the data to the processor. Then it will say ki yeah, there is no light right now. Then the processor will say okay, let me give the signal to the actuator. Like the actuator is the LED, and it will send the signal, okay, now it is the night time and you can turn on. Like this way we can automate street lights and all that things. This can be done like without using internet and all that things. Okay. And like we come to the conclusion that the sensors and actuators in the IoT work together like from opposite ends, but they work like simultaneously. Like we cannot give an actuator, like if you want to automate things, we need a sensor and an actuator. Like specifically in this slide, it is a use case for automated plant watering system. In this case, the sensor detects the soil moisture and sends the value to the controller. Like it have the logic program into it, and then the computer decides on the like base threshold. For example, if the soil moisture is below 10%, you have to turn on the water pump, or if the moisture is above 60%, you can turn off the water pump. This is a very basic example, and you will think that what will it do? But like if we see the bigger picture, we can save a lot of electricity and we can reduce human effort by just implementing this in your home or anything like that. And mostly if coming to the like complex use cases, the flow almost remains same, only the end components will change. Like we can have a temperature sensor and an AC on the other side. This would be temperature based air conditioning. Like if you have for example, the temperature based air conditioning, if the temperature of your room exceeds 30 degrees, then the AC will automatically turn on, and as soon as the temperature like get like is somewhat good, you can turn off the controller will automatically turn off the AC. And like we can have a light detecting sensor and an LED, as I told you. And then like coming to more complex use cases, to like more complex use cases, there can be like cold storage management. Like this will also have a similar flow, but with internet. For example, like the transportation of COVID vaccine, we'll have a temperature and a humidity sensor in the vaccine truck, the logistics part. And as soon as the temperature drops in the truck, it will initiate a buzzer in the driver cabin. Like also it can send the alert to the management via internet. The X-truck is like, for example, the the alert can be the X-truck is not maintaining the minimum temperature and it may destroy the whole shipment. Like as you can see, the whole process is same. Like we have a sensor, we have an actuator. The only thing that changes is the use case. Like in some cases we may not have sensor, but the mostly it is like this only. Like we have a sensor, then control center, and then an actuator. Okay. Anyone have any questions from this slide? Okay, no issues. Moving on to the next slide. So now we move on to the coding part, structure of an Arduino code. Like before like starting with the code thing, we need to understand like what is void setup, what is void loop. So before void setup, void loop, I would like to know that like to access any pin in the Arduino board, we need to define the pin number outside the setup and the loop function so that they are available globally, which means that they can be accessed throughout the program. Like for if I will define a pin or a number inside a setup or a loop, I won't be able to access it in other function. Like of course I can by using return or anything, but to make things easier, we define them outside these two blocks. Sorry, for example, if you want to define an LED, then like if you want to define an LED, then we will write here, like for example, above void setup. We will write here that int because like LED will give me an int out. Like is it like either it would be 0 or 1, like it would, because LED can't be like 50% wala thing in this case. So int LED is equals to the whatever pin number you want to give it. Like for example, I want to give it a 6 number. So I will define it here so that I can actually use it anywhere else, like globally. If I will define it in setup wala part, then I have to like return the value and the things get complicated. But to like make things simpler, we define it outside setup and loop so that I can access it inside the setup and then loop. Okay, now coming on to the setup and loop part. So it consists of like two functions, as you can see, and like setup is called when the sketch starts or your controller is like powered on if you have previously flashed the program. like we use it to initiate the variables, and like we have not initiated this, like we have declared int LED6. Is anyone speaking? I think. Oh, okay. So as you can see, like we have not initiated it, we have declared it outside. Like for initialization, like we have to, like we have just initialized an variable name LED, which is just like we have initiated. Now we want, like we have declared, now we want to tell the program key what it is. So what we will do, we'll go to the setup function and yeah, now we'll go to the setup function, and now we'll use it to initialize the variables like pin modes and what are the type of libraries that we want to use. And the setup will run only once in the program, it like after each power up or reset of the Arduino board. So now if you want to, like as I told you, we want to initialize LED. So like to initialize LED, we have a predefined function in it, which is called like pin mode. Sorry. Pin mode. This is case sensitive. LED, comma, input. Oops. LED is the name of variable that I have declared above, and input tells me key. Input tells the program that this is like this is an sensor, like this will give me input. Okay, semicolon of course. Yeah, and if like I would have defined another thing, so I would have write like, for example, if LED was for output, oh sorry, this is for output. If LED was for output, then I would have written output. That's it. By this way, like I'm declaring, I have initialized the variable, and now I've declared, I've told my program key LED will give the user the output. Okay, now this sums up the setup part. Now coming to the loop function, like after creating a setup function which initializes and sets the initial values, and then what it does is like we move on to loop function. Like loop function does precisely what its name suggests, right? And like it loops like it loops again and again and again and again, like until the program is stopped, or in any case you have turned off your board. So what happens is like it allows our program to change and like respond. Like we use it, it actively controls the Arduino board. What it does is, for example, in COVID vaccine wala truck, what will do is it will continuously check the temperature and humidity. For that, we need this loop function. Like in loop functions, we have like various functions, like predefined functions. As I told you, like we have digital and analog inputs. So for reading digital, we have digital write function, which is used to digital write is used to give command to the digital actuator. Then we have digital read, which is used to like take the input from a digital sensor. Then we have similarly analog for analog, also analog write, and then we have analog read. Yeah, like there are various functions. We can also define our functions outside these loops, which have like some logic in it, or if you want to perform some complex logic, so you can define them outside these like setup and loop, and then you can call them in loop, and you can actually pass them variables. And this is the basic programming knowledge of C language is required, but you can also do that without, like just after studying for some time, because it is not that hard. Then we have delay. Delay is a very important function, by the way. Delay tells, like as I told you, that loop function continuously iterates, then nobody asks me key when it will stop. So like we use delay to like pause the function for some time. Like if I said key, okay, give me the temperature reading of my COVID vaccine truck, what will happen is, like if I haven't put a delay in my program, it will continuously send me readings like after every millisecond, like after 1 millisecond, 2 millisecond, 3 millisecond. Like everyone will be irritated key, what is going on, why I'm getting so many outputs. And so delay is used to give a break to it. Like for example, key, okay, after taking a temperature, like after taking temperature, you should take temperature after 2 minutes. So yeah, in this, like we pass milliseconds, time in milliseconds, like for 1 second we give 1000 milliseconds. Any questions, anyone in this part? Okay. Yeah, now moving on to next. Let me just remove it. Okay, now this is an LED. As you can see, LED is like very like the most common actuator that we can see in our daily life also. So LED is an like abbreviation of light emitting diode or light emission diode, and is a device which emits light by flowing a current to the PN junction. PN junction, I think I don't know, like the doping wala thing and all that thing. PN junction is like a semiconductor laser which emits light. It emits like various wavelengths, and like it can also have like different colors, red, yellow, depending upon the doping level, how it is created and all that thing. It have two like pins. One is anode, the long one is anode, and the short one is cathode. Like we give like the positive polarity to anode and the negative polarity to cathode part. Okay, now I request everyone to please come to the Tinkercad or section. I will show you how to like do it in a like on an Arduino. Okay, so is everyone with me? Yeah. So this is a like I'll give you the basic of this UI. So this is a Tinkercad. As you can see, I have named the program like LED NKS 7.0. You can change it by clicking here. Then we have like coming to this section first. Now you can see you can select components from these parts. Like they have segregated like created categories: basics, all, starters, basic, Arduino. Microbit is also a microcontroller. Then we have circuit assemblies and all things. Yeah, so I've selected all. So now you can see like we have resistor, capacitor, diodes. Like we have like these are the sensors that I was showing you. They are mentioned with input because they give input to the controller. Push button, potentiometer, and yeah, you can see. Then we have output like LED, RGB LED, which is like red, green, blue. Then we have light bulb, neopixels, DC motors, servo motors, and 7-segment display, LCD screens to show you what it is like, what like to show the values like on the edge only. Then we have like battery and all that thing. Now let's start with the. I will show you how to interface an LED with an Arduino. So I'll take a breadboard from here. Zoom it out. Now after taking the breadboard, also like please sign into your Tinkercad accounts, and you can start doing simultaneously like as I'm doing. It will give you a gist of how to start with DIY projects. And should I wait for you to log into your Tinkercad, or shall I go? Can anyone answer from the audience? Please begin. Okay. Okay, so yeah, so this is a breadboard. Okay, now I'll use like Arduino Uno. Sorry. So now searching for LED. Now, okay, now we will start. Like we have the basic components, and we have the basic components, and now we will like build a circuit of LED, like a blinking LED. Okay. So what do you guys suggest? Should we code first or should we build the circuit? I think we should code first. So yeah, it have two, like you can code in two ways. One is the block way, you can directly like use it without like set the whole flow without using, without like, you don't have to type then, but we will use the old way. Next one. Sure, yes, of course. Okay. So let's start. So as you know, like we have two functions, void setup. Then we have void loop, which is used for iterating through the program. Okay. Now let's start. So this is the LED. Now in Tinkercad, you can actually see which part is like cathode and which is anode by just scrolling over it, like by hovering over it, not scrolling, sorry. Now, the first thing I like to do and I suggest you to do is like in the breadboard, take common 5 volt, okay, the power source, 5 volt, sorry. Yeah. And common ground. So the breadboard basics are key. If I have like given 5 volt here, so I have 5 volt common on this line, as you can see, it is being highlighted, the green line. So I have given the input here and I have the 5 volt on this whole line, and as I've given ground here, so I have the ground on this like complete line, and like coming on, like it is similar to like on this part and on this part. And the other part is like if I give a signal here, then I will have it in these 5, like in these 5 dots. Like we have the polarity here like this, and the common thing is over here. So now like I have taken the power and the ground from my board. What I'll do is I will place it here. Okay. Wait. Yeah. Now as you know, key I have taken the ground. So yeah, I will take the ground and connect it with here. So now I have make the ground connection of my LED. Now giving like coming on to the power wala part, I will not give power from here. Then what it will does is key, it will turn on the light as soon as I like, even without code, like as I did this start simulation. Yeah, as you see, like the light is glowing, but like I haven't coded anything. The error is that I haven't connected with a pin. I haven't given it any output from my board. I've just given like a basic circuit that is giving power to it, but we don't want to do that. So we'll like remove the 5 volt wala thing and we'll connect it with a pin, this part. For example, it's connected with 6 and color coded green. Yeah. Now let's code. Okay. So as you know, I've connected it with pin number 6. Yes. So I will define int LED is equals to 6. You can also change that, like for example, if I have done it like connected it on 1, for example, let's take 1 also. If I had connected with pin number 1, then I would have like mentioned here 1, and I would have made the connection from digital pin 1. We are using we are using digital pins here because LED is a digital actuator. Now coming on to setup, like we have declared the variable for LED. Now we have to like tell our board key what it is. So we will define pin mode. It is used to it is used to declare, like it is used to initialize the actuator or sensor, whatever you are using. So coming to pin mode, Now on pin mode, we will do like what is the name of my variable LED and specifying it. What will it do? Output. Yeah. I guess you guys are also doing with me. I think so. Then I will use digital write because this is a digital actuator. Then my name of the variable that I have initialized, LED. Okay, and we will tell it like, as you know, like we just have two states in digital, either low or high. So I want to turn the LED, so I will write high. Then we will just close it. Then, as I told you that we need delay in so that like if I just write LED high and I will start simulation, what you will see is that it will just turn on and do nothing. That's it. Like it won't turn off. Like, let me show you. Oh, sorry. It just turn on and like it won't blink. So I want, like, anyone want to tell me how would I make this LED blink? Anyone from the audience? Okay, so as I told you, yeah, please go ahead. Anyone is speaking, I think. Okay, so as I told you, like, why do we need delays in this? Like, we need delay to like give a pause to the program. So after like turning on the LED, I say like I want to like blink LED, my LED after every 3 seconds. So I give 3000 milliseconds. Then I would like give digital write my name of the variable, and then I will write low. And I would again write delay for 3000, or else like it will just turn on and like the blinking wouldn't be good. Okay, LED high, LED low, and this will iterate again and again. Okay, let's start simulation. As you can see, the light is blinking after every 3 seconds. You can see here. Yeah. This is just like a very basic code for implementing, like for implementing an actuator, and a digital actuator to be precise. You can see like I can change this. I can like connect n number of lights here and like make a light show on the breadboard itself. I can also like connect RGB light and then change the color from it, like taking 3 pins, like for one for R, one for G, and one for P. But this is just in red LED. Do anyone have any questions or anything? Just open the chat window. No questions. Okay. Now, stop simulation. So like I'll go through the code once again. I have initialized the LED. Okay, I see a question. Can you please brief a bit on digital pins? Okay. So as I told you, like we have a set of pins. So digital pins. Okay, I'll write here. So we have like, first of all, like let's take this like a little back. So we have two waveforms: digital waveform and like analog. So what is like in digital, we just have two things: either the input will be 0 or 1. Like in terms of coding, either it will be low, that is 0, or high. Okay. Now what like what Arduino, like the designers have done, like if you want to take an input from a digital pin, for oh, I don't know, yeah, wait a minute. If I want to take, yeah, so either we have like 0 or 1, or you can say low or high in digital. So what it does is we just have two outputs in our digital. So like to give, like to turn on LED, I wanted to let him know ki, okay, it is high. So yeah, I've written high over here, and then I want to turn it off. So it is written like low, which is like 0. Like give the 0, like don't give power to it. Like I'm actually, like what I'm doing is turning on and turning off power on these pins by giving them high and low. And like on analog, we have a range of outputs. Like analog, we may have 0 to 100. Depending upon the use case, we may have 0 to 10. And like these are continuous values. These, like in digital, we have discrete values. We won't have like 0.5 or anything like that. We'll just have two values, 0 or 1. While in analog, we have continuous values. So LED, like we cannot change the brightness of LED. Either it would be on, it would be off. So we are using digital pin for it. If you would have a LED which have the capability to turn, like have like we can change the brightness of it, then we would have used analog pins. Did I answer your question, Soumya? Okay, Srisharan, sir, while blinking. Okay. Sir, while blinking of LED, it is showing some symbol like exclamatory mark. Why, sir? Okay. So as you can see, this is like, we are doing this virtually. We don't have any hardware or right. Okay. So the exclamation marks shows us key, it is like turned on right now. And also one thing, like we have to add a resistor to it. Like, as you can see, current through the, like, if we will do this on a physical board, what we will need is we will have to add a resistor to it so that it doesn't like get burned off. So the exclamatory marks is telling me ki you don't know anything and you haven't like given a resistor into it. And it is also indicating that it, like presently it is turned on, and like when it is not, like it is turned off. I think that would answer your question, K. Sri Charan. Did I answer your question? Okay, I think I did that. Okay, now back to slides. Okay, so this was an actuator. I told you how to interface an actuator with your Arduino board. Now coming to PIR sensor. Okay. Now, can anyone tell me what is a PIR sensor? Anyone like want to take a guess or anything? You can unmute yourself and answer the question, or you can type in the chat box. Motion detector. Okay. Anyone else? Okay, no worries. So PIR sensor, PIR stands for passive infrared sensor. Like it detects the infrared rays that are like emitted from an object. The range of the sensor is like, this is a DIY sensor, so it is not an industrial grade sensor. So the range of the sensor lies between like I guess 5 meter to 12 meter, and like it can only detect general movement. Like it cannot give you information ki who or what move. Like it will only tell you ki there is a movement. That's it. It won't tell you ki okay, Akshay is moving in the office or anything like that. For that we need cameras, but it can tell you ki yeah, we have detected a motion. Now coming on to the sensor, like as you can see, it have 3 pins. LED had like, wait a minute. LED had 2 pins, anode and cathode, right? But in case of PIR sensor, we have 3 pins: ground, which is on the extreme left; signal, which is in the between, which is used to take the signal from the our sensor, and then we have the power one. Like we give the positive polarity on power, the negative polarity on ground, and the signal part in between, so that we can take the signal from it. It have a like infrared sensor beneath this white dome. This white dome is like, if you will see a Pir sensor physically, you will observe that this is like a dome type of thing. It is used to increase the range, like have a full 180-degree view. These are basically small, like I think deflecting material. This is like these deflect the infrared rays so that they can, like they have a wide range of area to cover. Like, okay, now, yeah, we'll again take a breadboard. Yeah, then we will take an Arduino. Okay. Oops. Yeah. Now, as I told you, we'll take power first of all. Okay. Sorry for my bad drawing, guys. Okay. Now I'll take, like, mark it as red so that you can. This is 5 volt. Okay. By the way, PIR sense Arduino gives two power outputs, that is 3.3 volt and 5 volt. We are using 5 volt because motion detector works on 5 volt. Okay. Now taking common ground. You can also directly connect it to your sensor or actuator. But the thing is, if you have more than one sensor actuator, you have to, like, it will be a mess to do that again and again. Like if you have a PIR and an LED and ultrasonic sensor, and like you are catering a very big, like a very bigger use case, and what will have is like you will have to give power and ground and again. But if you have done this like on the breadboard, you can take inputs from right here to like n number of devices. Okay. Now what we are doing? Okay, just close the chat window on that. Okay, now as you see, like we have taken 5 volt and then we have taken ground. Now we'll search for PIR sensor. Yeah, it is. I'll just put it on my breadboard. Now you can see, if you don't know the pin, when you do it on like hardware devices, you have to search for pinout diagrams. You can actually note that term, that is like you have to do that. Without doing that, you cannot implement this. You need to know the pinout, like which pin is doing what. Like in this, it's like in this sensor, the extreme left pin is used for signal, then this is for power, and this is for ground. Okay, now let's connect ground. I have connected ground to my ground. Now coming on to power, connected my power with my 5 volt. Okay, and now signal. Okay, now for signal, I think I would connect it with pin 7. Let's suppose. You can also like you can choose any pin number in your project. Green. Okay. Yeah. Okay. Now we have made the connections, but we have to code it so that we can actually get something out of it. Now, as you can see, this is blocks. Now we'll use the text wala part. Okay. Now, okay, we'll start. So the very basic thing is void setup to initialize like tell our board which pin will do what. Then we have void loop so that we can take values again and again. Now, as you can see, I have connected my PIR sensor, like the signal part, with my pin 7. And my power is 5 volt through this, and my ground is like connected to the ground of Arduino. Okay, now let's do like int PIR You can name it anything. Like for example, I can name it anything. Like I can name it X, Y, Z, whatever I want. Int PR is equals to then the pin number. As you can see, I have connected to pin 7. So I'll write pin 7. Okay. Now we will need a value. Like we'll need a let's say we'll need an integer in which we will store the value from PIR. Okay. Now coming on to setup. Now Arduino works on serial communication. So we have to like serial dot begin. Like we have to write this in every setup wala part so that we can like what say take the input from our sensors. Now we will also define baud rate 9600. We have like various baud rates in our Arduino. Baud rate is the transmission rate through like you see this cable in like on a real hardware. We need to connect this with your PC. So we have to define the baud rate, like on which rate you want to transmit your data. Mostly we use 9600. Okay. Now we will define key what is PIR. I still don't know, like I'm just a stupid code. I'm just a stupid board. I don't know what is PIR. So I will like now write it key. Okay. Pin mode. Let's say PIR. And what would I write here, guys? Input or output? You guys have to tell me, or else I won't write it. The chat window, I think, if anyone. You guys are saying, okay. It is in sensor. So we will write input because it will give input to our what say Arduino board. Okay. Now coming on to loop. Now we have to write basic logics. Okay. Value is equals to. Now I told you there were some functions. So this is a digital sensor. Like as you can see, we are taking input from a digital pin. If it would been have like an analog sensor, for example, a gas sensor or a temperature sensor. So temperature sensor would give me continuous values. Like temperature cannot be 0 or 1, right? So temperature would be like, it may be 20, 30, 40, like it will vary in a specific range. So that in that case, I would have connected my sensor in analog, like on these pins from A0 to A5. But it is a digital sensor. Like either it would tell ki there's a motion or there's not a motion. It won't tell me yeah, there's 20% motion and 70% not motion. That is not possible. So that is why we will use digital read function, and we'll pass the name of our variable that is assigned to that pin number. Now we'll use if function. If value double equals to high, like in like Soumya, I think Soumya asking the question ki why we are using digital pins. So at that time I told you in digital either we have high or low. Next, in motion, either we will have motion detected or not detected, right?
Actually, there's one more question from Jay. He's asking what is 9600?
Okay. So Jayant, 9600 is the baud rate. Baud rate is the rate of transmission, the like at which like serial dot begins tells the Arduino that we need to we need this to begin our serial communication. Arduino works on serial communication. So what will happen is if we won't specify this, we won't be able to get the data and push our code to it through our laptop. And like it changes from like 9600 to like there are many serial what's say baud rate. Let me show you. Like this is the Arduino Ide. Okay, so if you go to tools, you will see. Wait a minute. Oh, sorry. Serial monitor. I will show you when I'll run on serial monitor. This is the baud rate at which Arduino is transferring data from the laptop, like from your PC to your board, and from your like. This is the transmission rate. We need to specify this to burn our firmware on it. Now, did I answer your question, Jayant? If value is high, you can actually write. I'll write in the chat window. You can actually study its baud rate. Okay. If value is high, if I have gotten something is present in our surroundings, I will write serial like to show you guys key it is working. Serial dot print ln. This function is used to see the output in your serial monitor. Print ln is you like print into the next line, right? Motion DETCTD motion detected. Okay. Okay, now we have our if statement. Now we'll write our else statement. Now we'll write serial dot println no motion detected. Okay. And of course, I'm missing a thing. Delay. Delay is very important while doing your DIY projects, or else it will like give you a lot of values in a very less time, like in milliseconds. Like 4,000. Okay, let's reduce it. 4 seconds is way too much. 2 seconds. Okay, let's check the code. Let's check the connections. I have given 5 volt. Then I have connected my 5 volt to my power pin. Then ground. Then I have connected my ground to my ground pin. Okay. Then my digital input to the signal pin. And now coming to the code, I have specified a variable of type integer and given it like number 7. The digital pin, as you can see, I have connected to 7. Then int value to store the value from typo digital read PIR. Then if value double equals to high, I'm comparing like the value I'm getting is high, then I will print motion detected. I'll wait for 2 seconds and then this loop will again run. Now let's test it. Start. What's saying in function void loop error expected for constant. Oh, sorry. Oh, okay. Now I'll show you the serial monitor. As you can see, it is saying motion detected because like now you can see the line is like the light is on, which is saying the Arduino is on, and it is saying motion detected. Okay. Okay. So as you can see in while doing it on a emulator, what they have done is we can actually move our object. Like as you can see, this is the Pir sensor. This is the object. Now I will not like, and the red one is, and the red thing you can see is the range of our Pir sensor. So you can see the object is not inside the range. So my code is giving me no motion detected. As I will like, bring it to the range. See, you can see motion detected after every 2 seconds. Like I'm in the range of Pir sensor and it will show me motion detected. You can see like a red light on the Pir sensor also, but this is only on the emulator. It doesn't work on the real hardware. It is just for visualizing. Okay. Now if I'll like move my object away to say no motion detected. See. Now this is for like just for like I have the serial monitor, only I can see it. what if like I want to make it like, now we have interfaced a motion sensor, like stop, and we have interfaced in LED. Now let's combine them and make them like a motion based LED, like an automated LED. Whenever you will enter your room, your LED will turn on. Let's make that. So as you can see, now we have our Pir sensor. Now I need an actuator. Okay. Now I'll close the code section. I will search for an LED. I will connect my LED here. And as you can see, this is the cathode part. I'll connect it with the ground part. With the color black. Anode part. Okay. Now, tell me on which pin do you want me to connect LED? Like from 0 to 7 on digital. Which pin do you want me to do? Okay, I'll just connect it with, say, pin number 2. That you can see. Okay. Now I have an actuator also in my whole IoT system. Key, if I'll detect the motion, I'll turn on the light. Abhi tak I was just able to see it on my serial monitor. Now I can see it on my, let's say, on an LED also. But for that, I need to code, right? For coding, I will just like, I have a code ready for my Pir sensor, right? Let's close this. Someone was asking about baud rate, right? So I'll show you. When we do in our like real hardware, when we have our like hardware with us and we do it with Arduino Ide, so we can like, we have to select baud rate from here, and like on which baud rate you may have burned your code, you will have to select the same baud rate so that you can see the output on your serial monitor, of course. Now let's start. Now we have connected Pir to pin 7. Now we will do int LED is equals to pin, it is connected to pin number 2. Okay. Now I have to specify again LED is output because it's an actuator. I can also directly write a number over here, like I can just write 2, like for example, I can just write 2 and 7 here, but that would be confusing if you would have a lot of sensors. So I prefer giving names to the pins, like for example, now 7 is Pir, 2 is LED, and anyone who will see this code can actually tell that key. Pin 2 is assigned to LED and pin 7 is assigned to Pir. Okay. Motion detector. Now what I want to do is I also want to turn my light on. For turning my light on, I have to write digital, right? Because it is connected to digital pin, and the light can either be 0 or 1. It cannot be like 0.5 or 1. Like either it is off or it is on. It cannot be in the middle state. Digital, right? The name of my variable LED, and let's say hi. Sorry. Now coming to no motion detected. Also, I'm missing a thing. After like turning on the LED for, I'd say like just turn on for 3 seconds and then turn it off. Digital, right? So LED and say low. No motion detected. Then check again after 2 seconds. Yeah, that's fine. Motion detecting LED, high LED low. Okay. Now let's check our code. Let's check our connections. After like making your connection and doing your code, I would suggest you should always check your connection, because connections are the only thing that misses your circuit. If you have like right connections, your circuit would work. Like, see, okay, 7 is connected with signal, okay, and 7 is PIR, okay. Then we have power pin. Power pin is connected to 5 volt. I will also 5 volt. I will also suggest that whenever you start making a circuit, you should, like on the breadboard, you should take your power and ground on these common lines, so that you don't have to, like, if I would have made this, like, let me show you. If I would have like not done this, I would have done like, I would have taken a ground from here to here, then I would have taken a ground from, okay, I would have taken a ground from here to again, okay, wait a minute. Now, then I would have taken a ground from like here to again like here, and like power from like again यहाँ से इधर and from here to here. Like that would have messed my, like, you see it is not looking good also aesthetically, and you will be confused if you will add more and more things, because this is just a basic thing. Now let's start the simulation. Okay, CL monitor clear, so it is saying no motion detected, right? Now I'll give him something. So as you can see, like the LED is turned on as something comes near my motion, like my PIR sensor, like motion detected. Now I'll remove it, like it will turn on for 3 seconds, then it will turn it off. Like let's check that again. You see, so that is the very basic like how you can start with your DIY projects. And like as someone asked in the chat window, what should I do? So this is like one of the very basic thing that you can try to like get started with IoT. Like after that, like this is just without internet. When you have like done things like, for example, you have interfaced ultrasonic sensor, temperature sensor, and LEDs, motors, DC motors, step motors. When you have interface all that things, the next stage comes when like when you can implement MQTT. But that is a like after like you have implemented all these sensors and all these things. So do anyone have any questions? Because that's all from my side. How do you specify the range for the sensor? Well, this is a very different question. So like Soumya, for this PIR sensor, if you will like see the actual hardware of PIR sensor, they would have potential, like let me show you. See, so this is a PIR sensor which is available on Amazon. So you see, Soumya, these are like the potentiometer. These are given to these are here so that you can modify the range of your PIR sensor, the sensitivity and the range of PIR sensor. But this is just a like a DIY sensor. It is not made for some industrial grade application. So I suggest that we can modify our range from here, but you should not do that in this sensor, specifically this sensor, because then it would give you garbage values, like you are not moving, but it will tell us motion is detected. And are you getting what I'm trying to say? Like in PIR, you can modify the range of the sensor, but like if we are using temperature sensor, then the range will depend upon the sensor, right? Like PIR will only tell me 0 or 1, like motion detected or motion not detected. But the temperature can, like, it is completely depend upon environmental factors. You can change the sensitivity of a sensor if they have given the what say provision for that. This is just a potentiometer to change the like how much light would an IR infrared sensor would send or receive. Did I answer your question, Soumya? Okay. So now we will have a Q&A session. Do anyone have any question for me, for Vinay sir, for Saurabh sir? Over to Sakshi ma'am. Okay.
Thank you, Akshay. Akshay, we have some questions here. So Hemlata wants to know, PIR senses only when there is a motion, or?
Yes. PI sensor is it only senses when there is a motion, because this is like just a start to a bigger picture. So it is just a very basic thing.
Okay, thank you. For for a use case where you have to switch on the light only when the person is inside the room.
Yes.
And if the person is not inside the room, you have to switch it off. So
Yes.
for this kind of a use case, what kind of sensor can we use?
Okay, so you can use PIR sensor.
No, we have tried using it, but when we use that, if the person is sitting static, right? Once the person comes to a place and they sit in the place, and when there is a no motion, right? Let us assume they're watching something in the laptop or doing something in the laptop. There will not be much of the motion, right? So at that time, it automatically switches off the light.
Okay, so for that what you can do is you can use a ultrasonic sensor. Okay, what it will does is whenever the person like put the ultrasonic sensor on the entry of the room. Okay, when the person comes into the room, your sensor would actually like be on a on state. Okay, and when the like you have a PIR sensor inside, it will detect the motion. So you'd have a two-stage validation. Yeah, someone entered the room and it was a person, right? Like first of all, the door opened. Ultrasonic sensor would catch that. Then PIR motion would sense कि yeah, someone passed the the bed of your room. That will like you have to create that logic in your code, and you can use an ultrasonic sensor and a PIR sensor to cater that thing. Now when the person will move out of the room, it will first come to like the bed, like it will like get off the bed, and then it will go to the room, like the exit of the room. In that case, you will write the logic key. Okay, first my motion sensor detected the motion, and then my ultrasonic sensor detected the motion. Now it will like turn off the light. Like, did I make something clear?
Yeah. What if the person is already inside and they are making a motion and someone else enters the room?
See, we can have a lot of use cases. Then this is just a DIY project type of thing, right?
Yeah, but
like for that, like whatever you're saying, we cannot implement that on Arduino. For that, we will need a more powerful board. For example, I'll tell you, you'll need a Raspberry Pi first of all. Then you will need a Raspberry Pi camera, and you have to implement TensorFlow. TensorFlow is in machine learning. No, it's a Python library that actually detects whether the person is sitting inside or not. Like that is a Himlata, that is a very big application you are saying.
okay.
You can achieve anything, but for that you will need a Raspberry Pi, like a powerful board that have the capabilities to connect to the internet and take input from the camera, then run some algorithms like TensorFlow. TensorFlow is a very I think you must have heard of it. TensorFlow is very common.
Okay.
Keras, TensorFlow.
Yeah.
Did I answer your question, or like?
Yes.
Okay.
Yes, thank you.
Yeah, and also you can also connect with us on our LinkedIn page, and also you can directly contact me on LinkedIn. You can just have to search Akshay Kumar IoT Engineer, Napino Digital Solutions. I will be there, or you can directly post your queries on our event page. Also, we are having our next event, smart agriculture event. Any more questions, guys? Over to you, Sakshi ma'am.
Thank you, Akshay. Guys, if you have so many questions, once you try this on your own after this event or after this training session, You can always, go back to our LinkedIn page, the event page, and you can drop the questions. And if you have any other queries that you don't want to publish that on a public platform, you can always email at info@napino.com. So I've dropped the email ID on the chat window. And also, it will be great if you can share your feedback of the session. I know it's a bit long, but the value that you have received on this session is quite high, like coming directly from the experts who are working on the live projects in the company. Thank you, Vinay and Saurabh, for sharing your insights and learning on IoT and hardware in the ODM. That was a great session. We have our next event on September 25. That's the last Saturday of the next month. It's on smart agriculture. It will not be a training session, but a panel discussion where we'll be having top leaders from the agriculture industry who are implementing IoT products or deployment in their farming practices and reaping the results. I'll share my screen, and for the more details, you can take a screenshot for the next session. If you want to attend, you can register yourself. Is it visible? Yes. Once again, thank you all for showing up on the Saturday morning. I hope it was productive for you, and you'll have got a good learning here.
Yes, I think I didn't bore you guys.
Okay. For on this note, we'll end up the session. The screen will be visible for a minute more, and all the details are on the chat window. We are looking forward to hear from you on the feedback, on the questions, and on the next sessions, or any other way that you want to connect with Napino Digital Solutions. Thank you, everyone.